Hey everyone, it's Dr. Jess. Welcome and welcome back to my channel. In today's video, we're going to go over how to draw Lewis structure for atoms, molecular compounds, and polyatomic ions. If you're new here, please don't forget to subscribe to the channel and turn on your notification bell so you don't miss out on any new uploaded videos. Okay, let's get started. Before we talk about Lewis symbol, we need to first understand what valence electrons are. So valence electrons are electrons in the outermost energy level. The group number that each atom belongs to indicate the number of valence electrons. So for example, sodium belongs to group 1A, so that means it has one valence electron. The Lewis symbol represents the valence electrons and they are shown as dots. So let's take a look at a few examples. Let's draw the Lewis structure for aluminum. So aluminum belongs to group 3A, so it has 3 valence electrons. When there's 1 to 4 valence electrons, they're shown as single dots. They're arranged as single dots. But when there's 5 to 8 valence electrons, some of the electrons are going to be paired. So with aluminum, it's 3 valence electrons, so it's going to be arranged as 3 single dots. For bromine, for example, bromine belongs to group 7A, so that means it has 7 valence electrons. So you have 3 pairs and 1 single. Phosphorus belongs to group 5A, so it has 5 valence electrons. So you'll have 1 pair and then 3 single. Now let's take a look at how to draw the Lewis structure for molecular compounds. So in molecular compounds, the valence electrons of all the atoms are arranged to give octets, except for hydrogen, which has 2 electrons. So the shared electrons are shown either as 2 dots or as a single line between the atoms. So let's take a look at an example. Let's draw the molecular structure, the Lewis structure for F2. So each fluorine atom, so fluorine belongs to group 7A, so that means each atom has 7 electrons, 7 valence electrons. So that means each atoms will have 3 paired electrons and 1 unpaired electrons. So each of the fluorine atom can achieve an octet by sharing its unpaired valence electron. So we can see on the left hand side, the shared valence electron is shown as 2 dots, and on the right hand side, the shared electron is shown as a single line. Now let's talk about how to draw the Lewis structure for polyatomic ions. So let's look at an example. Write the Lewis structure for ClO2 minus. So first we need to determine the arrangement of the atoms. So here chlorine Cl is going to be the central atom because there's only one Cl atom. Next, we need to determine the total number of valence electrons. So oxygen belongs to group 6A, so 6 valence electrons, and there's 2 of them, so 6 times 2 equals 12. Cl, group 7A, so 7 valence electron, so 12 plus 7, that's 19. We have 1 ionic negative charge, so we need to add it to the valence electron, so 19 plus 1 equals 20. So we have a total of 20 valence electrons that we need to place. Now, we know that each oxygen atom is going to bond with the chlorine atom with the pair of electrons. So that pair of electrons can either be shown as 2 dots or as a single line. So by bonding the Cl with the 2 oxygen, so we already used 4 electrons, so 4 valence electrons. Now we're left with 16. So we're going to use the remaining electrons to complete octets. So oxygen needs each of the oxygen needs 6 more electrons to complete an octet. So you're going to have 3 pairs of electrons on each of the oxygen atoms. So that's 6 plus 6, 12. We already used 4, so that's 16. We're left with 4 electrons. The remaining 4 electrons, we're going to add it to the chlorine atom to complete that octet. So when you add the 4 remaining electrons, so the 2 pairs of electrons to the chlorine, then we'll have an octet on the chlorine atom. Now, if we look at everything, we see that oxygen is an octet, chlorine is an octet, and then the second oxygen is also an octet. And then for polyatomic ion, we put them in bracket, and then we put the charge as on the right hand side the top right hand side. Lastly, let's go over how to draw the Lewis structure when we have multiple bonds. So let's take a look at this example. Write the Lewis structure for carbon dioxide. So first, we need to determine which is going to be the central atom, and that is carbon. Next, we need to calculate the total number of valence electrons. So carbon has 4 valence electrons, and each of the oxygen has 6 valence electrons. So that's 4 plus 6 times 2, 12. So 4 plus 12, that's 16. So we have 16 total number of valence electrons that we need to place. Okay, so next, let's try, if we look at the first answer, okay, let's see why that's wrong. So let's try to bond each of the oxygen with the carbon with a single bond. Okay, so by doing that, then we used already 4 valence electrons. So that means we have 12 valence electrons left. So remember, we're going to use the remaining to complete octets. So if we add 6 valence electrons to each oxygen, we can see that we use all of our electrons, all of our remaining electrons. But let's look at this. Each oxygen is an octet, but if we look at the carbon, we see that the carbon is not an octet. So now, so that's how we know that is not the right answer. That is not how you draw the Lewis structure for carbon dioxide. Now, let's look at the second example when we use double bonds between the carbon and the oxygen. So by using the 2 double bonds, that's already 8 valence electrons that we use there. So that means we have 8 valence electrons left. So we need 4 more electrons for each of the oxygens. Okay, so that's 8. So that means we're done. No more valence electrons left. So let's take a look and see if everything is an octet. The left oxygen is an octet, so 2 plus 2, 4, and then the double bond, so that's 8 electrons. The second oxygen on the right hand side is an octet, so that's good. The carbon in the middle is now an octet. Can you see that with the double bond? Now, with the double bonds, the carbon in the middle is now an octet. So that's how we know that the second option is the right way to draw the Lewis structure for carbon dioxide and not the first option. So you have to make sure that you have an octet. So that's how you know. Let me know in the comments how you would draw the Lewis structure for ammonia, NH3. Okay, that's it for today. Please don't forget to like the video, subscribe to the channel, and turn on your notification bell so you don't miss out on any new uploaded video. Okay, I'll see you in the next one. Bye.